All right. So now that I'm recording, let's work on the lab. All right. So the lab today is to understand how to create and use tuples. Specifically, I'm going to show you how to put them into a list because the project very specifically says that you have each card being a tuple and that the deck of cards will be a list holding tuples. Why am I that specific? Because the things we're practicing for this. Are there many complex ways to write the card game project? Yes, but we're going to keep it very simple and very text-based. No graphics. Don't go looking for graphics. All right. So what I want to do is there's several exercises here. We're going to start at the top. The first one is to create 3 people. Their card. So, and I'm going to be honest with you, I'm going to do this all in main because it's just examples. It's no functions for today. So exercise 1, create 3 tuples that represent playing card. Each tuple should contain a suit and a value. Now, I didn't tell you which suit, which value, so this can be any 3 cards you want to create. Right? So tuples are created by using the parentheses with the items inside separated by commas. So this could be our card. That's card 1. And oddly enough, I can make card 2, and card 3, right? Now, a card can either have a number value or it can have a face value, right? So your tuples sometimes will be 2 strings and sometimes will be a string and a number. Now, so let's make this one. So when you do that, they're pretty simple. But to make sure that we did it and it works, we can now go down. I'm all about the testing. Now this won't be formatted really pretty because I'm just going to print them one right after each other. But let's run it. Oops, it's not going to run. Forgot to call my main. Why did it not just go to the desktop? That would be too easy. All right. So, and it prints them. So I know that they create it, right? So the next thing it asks us to do in this lab is to store them in a list. I have card 1, card 2, and card 3. I'm gonna back up here. And I'm gonna create a deck, right? And I'm gonna create the deck as an empty list to begin with. Why? Because I want to show you how to add things the proper way. And then I can do deck dot end. And now instead of printing all the tuples, I'm going to ask it to print the deck, right? And I'm going to test it again. And now I have my tuples inside of square brackets, which indicates that it's a list with tuples. Yes? So remember, the square brackets indicate that it's a list. Parentheses around things separated with commas indicate it's a tuple. Now, you have to make 52 cards for project. Should you write 52 lines of code to do this? No, this very, very obviously, at least to me, is a time you want to use loops. You will have a function that creates that, but inside that function, you can have loops to do this. Would you like me to show you? It's not really part of this lab, but I figure y'all don't care. So instead of doing it individually up here, I could create myself a list of suits. Oh, brain dead. Spades.
Oops.
Thank you. I do know these things. And then what do you want to call the numbers? We just call them values. And I'm not going to list them all out because I don't want to be here all day, but pretty much you could have 2, 3, 4, 5, 6, 7, 8, 9, and then it's going to jump into ace, etc. Right? So I can have a list that looks like that. Or so I'll have 2 lists. Now I can do what we will do for. I still can't. 4. Suit in suits. Right? So that for loop will do each suit one at a time. You're going to nest your for loops because now I need a for loop that's going to go through each of the values for each suit, right? So you're going to have a for loop inside of a for loop. Right? That makes sense? Yes. This is where you ask me questions. If you don't understand it, don't make me read your facial expressions, especially if you're in the back, because I can't really see your facial expressions. All right. So what this does is the first for loop says I want to go through each of the different suits. While I'm on each suit, I want to start the second for loop. So our first suit is hearts. So the first time through the outer loop, we're going to be doing the hearts cards, right? 13 of them. Right? Is that right? Yeah. The second loop is going to then assign a value to each one of them. We're not going to do 13 this time because I didn't put all the different face cards up there, but are we good? You following me? So the outer loop's going to run every time we change suit. The inner loop's going to change the value of each card. The two loops together should create 52 cards. Now, when I create those 52 cards, I need to store them somewhere, right? So I need to append my deck. Well, I didn't create a deck. So let's go back up and create an empty deck to put them in. Right? Now, where do I want to append the deck? Inside of which loop? Because it matters.
After you make the card,
Yeah, after you make the card. But if you do the indents wrong and it's not in this, so I want to append deck here. If it was one less indent in, it would only make 4 cards. Does that make sense? So all of this down here, I want to comment out. Trying to remember, not Java, not Java. No, that's not right. The slash. That's right. Thank you. Because C# does it one way, Python does it another way, and Java does it an even different way. All right. So I commented out too much because I still want to print my deck. So if I run it now, I should get a bunch of cards. Oops. What? Wait a minute, it doesn't like my indents. I gotcha. I get you. Talking to your computer makes it so much better. Why is that one unexpected? the biggest pet peeve I have with Python is the indentations and the spacing because it only takes one space to screw it all up. So now my list holds a whole bunch of cards. So it did all of the hearts first, then it did all the diamonds, then it did all the spades, then it did all of the clubs. This is why you need that random dot shuffle, because otherwise, when you start playing this game, you're gonna get all the hearts, then you're gonna get all the, and they're gonna be in order. And you know, not much of a game. Challenge them if you can count cards. Right? You get in trouble for that in Vegas, so don't count cards in Vegas. I don't know how anybody does it, but you know, there's I don't know. I've never been to Vegas, so I can't really help you with that.
Messed up if you say that you don't count the cards, that you don't put the orders that we.
Yeah, if you don't use the shuffle function that I'm talking about at the beginning of class, the cards are going to be created in your deck in order. And so there's really not a challenge to that if you know the next card being dealt is gonna what number it is, because then you could figure out whether it's your turn or their turn. Yeah. So all right, how are we feeling about tuples so far? Anybody here think it looks an awful lot like a special list? Yeah, that's because they're a special list. So if I want to find out what the suit is, I want index 0. If I want to find out what the value is, I want index 1 of the tuple, right? And you will have to write logic to check things, especially when you get to the face cards. If it's one of the face cards, you're going to have to go and put the value in. And most of the face cards are easy. If it's a string, you just know it's 10 points, right? Except for that silly little ace. Because in blackjack or 21, the ace is either a 1 or an 11. So you're going to have to write some if statements based on what your total is at that point, to whether your ace is going to count as a 1 or an 11. Because if it's going to put you over 21 and make you lose the game, you want it to count as a 1. If it's going to put you closer to 21, you want to count it as an 11. Will make you feel better. We're going to spend a whole week in class with me answering questions about your project too. All right. So pretty much have done exercise 4 for you now. I've added more cards. I've showed you how to print the whole list of tuples, which is part of 3. But if we only want to print part of one, I haven't shown you how to get a specific piece of value, a piece of data out of it. So let's say we want a card. And it's going to be equal to, we'll do card 15. I don't know what card 15 is, but we'll do, is it parentheses for square brackets, right? It sucks to get old. Just telling you, it sucks to get old. So a card is going to be card 15 out of our deck. I don't know which one that is because I didn't count. But it's going to get us a card. When we play our game, we might want it to print prettier. We might not want it to print a tuple with the parentheses and stuff around it. So you might want to get the individual pieces out to print them. So I want it to print the suit, just the suit of card 15, right? So And the indexing for tuples, oddly enough, looks exactly like the indexing for a list. So let's see if my code works. So I just got one piece of my tuple out. Now, can tuples have more than two things in them? Yes, absolutely. It can be much longer. It can be like a list. They could have lots of items in them. When people first started teaching me Java, when people first started teaching me Python, I read tuples. Oh, that's probably just a two thing because it sounded cool, but no, they're actually can be much longer. I also, you will find when you start reading my program and lab descriptions, I often misspell tuple. So sorry. And spell check won't always catch it because I get the L and the E mixed up. Sometimes it's LE, sometimes it's EL. So don't judge me if you catch a typo in my stuff. I'm typing a lot. Yes, ma'am.
So for the values, when you assign values to 2 through 9, that's like the number on each card, right?
Mm-hmm. The 2 through 9 are the numbers on the non-face cards. The face cards will have to, you will have to put in there that it's a king, a queen, or a jack. You can't just put 10 in there because there's no way to individualize which card it is. You have to, because you can only have 52 cards and you can't have duplicate cards.
That's why it's
Because if you do, you're cheating. If you have duplicate cards, you're cheating. You're cheating. You also can't short your deck cards because again, that's cheating. If you take out all the high value cards, then it makes it harder to get to 21.
it's number.
Yeah. So how are we feeling about tuples so far? So I've done all 5 parts of this exercise for you. And if you were smart, you wrote all this down where you can turn it in and use it when you start planning out your decks. So, questions for me? No questions?
Didn't do all 5.
Which ones? Oh, I didn't do the condition check. Sorry. I removed the check if any card in the deck is an ace. Okay. Sorry. I just skipped one. It's all right. It happens. So how do I want to do this? What does it say, right? So I'm gonna use a for each loop again because it's a list. So what else would you use? For a card in deck, or for every card in the deck, I want to check the value and see if it's equal to ace. Right? Or actually, it wants to check to see if there is an ace in the deck at all. So you can do this 2 ways. There is actually a function for lists that you can see if it contains something. But I'm going to do it the way that we mostly have done it in class. I'm just going to write the loop. And luckily I put ace into my deck, so. Right. So if you were doing this as a function and not just print statements, you could have it return true or false instead of printing out a statement. So once it found one, you could just have it return true out of the function. Does that make sense? All right. So let's run it one time and find an ace, and then we'll run it again and not find an ace. Now, why did it do it that many times? Because my indents are wrong, and then it ended up inside one of the loops.
It's got going.
Yeah. Or what I really did, I didn't break from the for loop, but it still continued checking the rest of the cards.
Isn't that what a while loop would basically do?
Now you can put a break in there. So what I've got written here technically works. It's going to check to see if every card is an ace or not. I don't really need the elk to print that it's not an ace because I don't really care. But what I could do, once I found that ace, I could put a break right here, and then it will stop checking. So as soon as it finds the first ace, it'll stop because it hits break.
Oh, keep going and asking.
Yeah, so it puts the brake on and you jump out of everything.
Why is that for the for loop? Why was it that it just kept continuing again? Because you didn't have the blink?
Because it had to finish all the cards. It did everything in the deck.
Oh, it did all 50.
Yeah. Or all the ones I made. I didn't actually make a subset of that. But if you're just trying to find out if there's one in there, you can stop after you found the first one. So you can put a break in once your if statement's true. Does that make sense?
Mm-hmm.
If you need to count how many aces are in there, don't put the break in there. Put your counter in there instead of a print state and count it. Like we do with the ABCs and the grade, right? So if you think about it, like with the exception of the tuples part, you have done everything you need to put this game together. You've done the if statements to check the values. You've done the for loops to look through every item in a list. You know how to add things to a list. You know how to subtract things from a list. Yeah. And why do I say, do I have to subtract things from a list? Because once you deal a card, you got to pop it out of your list or remove it from your list. Because if you don't, it could be dealt again. That makes sense? And the reason you can use pop is because when you're dealing, it's always the first card or the one off the top of the deck. So in a list, that would be the last one, which you pop off. You have to visualize it. Make sure you shuffle. Make sure you remove the card once you deal it. Make sure you add all 52 cards to the deck. There's a lot of little nitpicky, tedious steps coming at you. All right. So that's one way of doing this. You can go look up the function for a list where you can check to see if it contains something. I don't care how you do it. I know you know how to do it this way because we've done it in class this way. For your general knowledge, I have actually gone into ChatGPT and Copilot and got their version of this final project. I know what it looks like. Don't do it. It's pretty obvious because they do things that I haven't taught you. It's perfectly correct. It's just above the scope of this course. So I just took ace out of my list for creating the cards to prove to you that it won't print that there's aces. Yes. You could put an out statement in if you wanted to. That says no aces found, but just make sure you print it after. And dent it back one where it prints outside of the loop. Are we good?
So are you saying write the else statement like outside of the?
No, the else statement has to stay with the if. But when you the else has to stay here, but you may want to keep it as a variable that you print later that says no aces found or account for something that stays at 0, just where you don't print it out a bunch of times. But that's formatting stuff that you should do last. Get the functionality of it, whatever you're doing working first, then go make it pretty. Yeah. So, that's all I have today. So if you're good, submit what I just did in the assignment lab thing, and you'll get credit for having been here and participated. If you have questions, stick around, ask me questions. It looks like we've got about 30 minutes before we have to be out of here. Yes, sir. Okay. You want me to look at your code? Okay. If you want me to look at your code, you have an individual question, stay put. Don't move. I'll come to you. If you are done, see you Tuesday. Thursday. Yeah, it's Thursday. I usually do this on Thursday. So I'll see you Tuesday. Thursday. Whatever. I'll see you next time. Yeah, just a second.